Okay, so I want to believe you can see my screen, and I am happy I saved all the I didn't delete all the queries that we ran last week. So I want to believe we still have them here. So looking through these, I want to believe these are those queries that we ran. So let me bring those questions up. The first question was talking about, I want to believe you can see my screen now. And I'm doing this just prime our mind so that by the time we're getting into the depth we'll be going into tonight, it won't be too strange because our minds will have been primed. Um, and by the time we'll be putting these new coatings on it, it won't be falling off. If you don't prime a wall and you start painting, there is likelihood of those paints washing off, or you're applying a POP material on the wall without priming. Okay, so let's get to what was, and then we get into something different. Not different, maybe we're just moving a step ahead. All right, so the first that we solved last week was to see, playing out a scenario as a sales manager. You want to identify the top five customer who made the highest total purchases. The highest total payment now. How would you find information by combining customer and payment data? And um, we have hints. So we have hints to guide us to what we're looking for. And the hint we have tonight is, or on this first question, is that we'll be combining the customer and the payment data. And remember that I've always mentioned that one of the things that will help you to know, even without the hint, what goes on in the data set is to actually get to see um, the, the diagram and that shows the relationship in the data. So, and you can get to that through your database. On the MySQL workbench. So reverse engineer, and once you just do your next and you put in your correct password, and if your password is correct, you'll be able to get into the diagram. All right. So, and once you get in there, you'll be able to know what relationship exists between this uh, each of each of the tables. So let me reduce this to 75. And I think I did an arrangement that was perfect towards the end of last week, the last class. And I would like to do that again. And I pray it works that way again. Okay. Okay. Just to make sure nothing is crossing into another, and that we can see everything at once. All right. So with this, you can tell which table contain what, and if you're looking for this, how do you then move from one table to the other? Remember, that's the essence of joins, and that's the essence of joins. And we're able to do a lot of joins last week, and I'll just be going over to the query. We then get into understanding how those tables connect. So, one of the things we established last week is, if for instance you want to get into this table, this is orders table. So if you want to get into this table, there's a way to reduce this to make this bigger. It's not coming up. All right. So if you want to get into this table called order, so you can see that order the table header is connected only to directly connected to customer table and order details table. But say for instance you want to pick something from order table and you want something from offices table. So you should then check which route should you go. And from this diagram we could see that we can move from order to table, table to employee, and employee to offices. Let's assume we needed an information that is contained in order and offices table. So we need to then join this table to get us what we want. And okay, so and that was what we did, and we have all of these queries. I think this is for the first. Um, this is for the first question where we needed the customer who had made the most sales. So, and there we talked about earlier where we introduce the as word, and which is also um, the same as what we have as also known as. So that is what prompted the as here. Like I said, this is a language that is very similar to human language, and as a result, you'll be seeing most of the keyword that SQL deploys is very similar to human language, and you can just decode, and it helps you to remember this syntax anytime, or this query, or how to combine words to make sense in SQL. So we have this as, and then we presented it this way, and we performed inner join on this particular table, that is table customers and table payments, so as to make this table become one, and then we'll be able to get what we want. I mean, we'll be able to select using the SQL keyword now. We'll be able to select from the table, having joined them together, the customer name and as well the total payment. But we want it to be for the top five. We want it to be for the top five, and that is why we come to a point of ordering it by the total payment. So we want to order it by that payment that was made, and by the time we order it and we make it in descending order, so the DEXC is actually standing for descending, for descent. So it means that we want to order in descending. We want to order payments in descending order, or we want to arrange payments, so to say, in descending order. So, and that means the bigger ones will be at the top, and since descending the next lower till the list of the numbers. But we need just the five and the top five from the question. We need the top five from the question, and that is what will bring us to the point where we'll now say limit it to five. So arrange it in descending order, but all we need is just the top five. And with that, if I should run this query now, ordering venue call, we should have that. All right. So we have these top five customer that we're dealing with for excuse me please. We have these top five that we've been that have made it most payment in the store, and then we move on to the second question, which says that the finance team need a report of all other along with their respective customer contact detail. How would you retrieve this data using order uh, and customer tables? Remember, there is a direct relationship between customer and the other table, so it is very easy, because what we need is that we need all the order, but against each of those order, we need we need um, the customer contact. Yeah, we need the customer contact. So and the customer contact is contained in this table. The customer contact is contained in the customer table. So we can then move over and then achieve what we'll have to achieve by writing a query of this format. So and what are the customer contact that we have? We have the contact first name, we have the contact last name, and we have the phone. But remember, in the other hand, we just want to pick the order number and the order date, or possibly the order status, just for us to know if it was um, what status the order is, if it was fulfilled or not fulfilled. And we just did this is quite easy to pull because we just to join the table and then we run. We're not to order about anything because what we need is just those record. And if things being equal, same time, these are what should run. So this gives us the whole of it, and we have a message here telling us that we have that is 326 rows that was returned by this query. Okay, all right. So and then we'll move on to the next one, which is the third question, and was saying the operation teams want to know the total quantity of each item ordered by customer in a specific country. So we specified the country last year, and I said last year, last week, and I think we went with the United States of America, and we pull up this query that we want to see the total quantity of 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 each product that was ordered by a customer in the United States, and that was what we did in this next query. Okay, so that is not here. Um, then we can just write that now. So let's just write that as a way of reminding ourselves. Okay, yeah. At this point, I was about writing, but an instinct tells me not to write. So I will call someone from the class, or anybody should just indicate if you want to write this.
Yeah, let me
Oh, okay,
try.
great. So please, let's see if you will be able to share your screen first. But if you won't be able to share your screen, you will just guide me. Attempt sharing your screen. Are you able to stop sharing? But I mean, it should not have prevented you, but I'll just stop sharing. Can you then share? Okay,
No,
now yes. Yes, yes.
so I don't, that should be this one. I don't know. I already write the code for,
Yes. If you have written it, no problem. Just talk us through it. And after this, I'll be making a comment after this. Okay, please, if you have written it, no problem. You don't have to wipe it. Just talk us through it.
it should be this number two, right? This one, the finance team need a report on all others along. Is it this one
No,
or
should be
this
the
one?
next one after this.
Okay, this one.
No, we need the one for the country. Yes. Yes, this.
Okay, so the
So,
operational team wants to know the total quantity of each product ordered by customer in a specific country. So what I used in my case was France. I think I used France. France. So first, from the table customer, return alias in C, and I'll join it with orders. And let me see my screenshots here. Okay, what was indicated here is how to join the customer order and order details table. And then when I check from my table connection, I discovered I need one of the tables that was not listed there, which is, let's see, I'm trying to scroll down the screen. Okay, what was listed there was orders, order details, and then customer. And then I added product to be able to see the sum of product that was purchased. So I joined orders I checked the relationship between orders and order details, which is on customer number. I joined those two tables and then joined order number, okay, or join order details on order numbers. Join product to be able to get the product and sum of product. I join product with order details. That's the table that's related, which is this one. And then selected country grouped by product name. So this is the result I got, which is the country, the sum of the product, then the product name.
All right. Thank you. Thank you very much. I mean, I appreciate the fact that you even stepped out to explain this, and the fact that you have actually done this before the class. I think that is worthy of note, and like sincere appreciation to you for taking out time to do that. All right. So I said I will be passing a comment afterwards. As a data professional, I was making a point of you trying and also um be ready to share what you've done. Be ready to share what you've done. I'm very sure, Doctor, I've always emphasized this because as a data professional, we're more of a storyteller. So we tell story. So we should always be ready to share about what we're doing because that is what you do. Because you'll be in a management meeting presenting your findings, and sometimes you could have the best dashboard, you could have the best report, but if you're unable to present it in such a way that people will be convinced of what you say. So we must actually add that to our soft skill. So it is a soft skill that we must own, which is presentation. And at times you might not even be the one that have done the report, but because you are the lead. So because we're not training people who will just be book pushers. We're not training people who will not ascend to becoming managers. We're not training people who will not become CTOs. But if you don't know how to present your report or your findings, it will be very hard, and that could be something that will differentiate you and somebody who does not even know as much as you do. But because he has that skill to present, the person will be preferred to you. And I pray that won't happen to you. You will always have the best slot that you desire. So thank you, Mr. Mene, for that presentation. And I will be going to Oye very soon. But just maybe let me just write this up for the sake of me having this here on the screen. he actually displayed it, but let me just write it up here so that I can just keep a library for it. And I don't know why this was not stored from the last time. So the question again is the operation teams want to know the total quantity of product ordered by customer in a specific country. So they want to know the total quantity of product that was ordered in a specific country. So, and it is very easy. So we're breaking it down in this fashion so that you will know that all the questions you will get to be asked in real life are not things that you cannot answer. All right. Um, so, uh, all right. So they want to know the total number. Okay. So yes, I see why this is here. I now remember why this is here. This was when we were trying to know um, what are the different what's it called? What are the different countries that we have? What are the different countries that we have? So I think that was when we
Sorry, but
Are
I
you
don't know if
sharing
primarily
I'm
your
the only
screen?
one. We cannot see your screen.
oh, I stopped sharing the last time. I didn't start sharing again. Sorry. Since I stopped sharing, I didn't share again. Okay. So I was wondering where this was coming from. And I remember that we were trying to know um, the the countries that we have because I want to believe that it is in customer that we have the column countries. So we're trying to check, okay, what are the countries that we have? And this is how you check sometimes. Yeah, you can come and just check what is even in my table. From the diagram, we're able to see that country is in customer. So we want to see all the countries in um, in customer. So or the column country. So we just say run, and it brings that out the country. So and we saw all. So if if in a way this is with repetition, we can introduce what we call distinct, which is a keyword as well. So we said we should respect our keywords and have them in capital. Okay, so distinct. Okay, so we want to have distinct country. Okay, want to have distinct country. So you'll see the difference between having distinct country and just having country. So now we set country and it gave us for each of the roles that we have, it gave us the country, the corresponding country. But we now say no, I don't want you to project it this way because there is something that is called optimization. So you want to optimize your machine space. You don't just want to be running because it will bring you I mean it will bring you out a result, but you want to optimize your queries. You don't just want to be running everything. Yes, it has given us what we needed, but this is not optimized. This is not optimized. Why should we have USA twice? Because we don't need it. We just needed the distinct country. And so if we should run this, so this makes it better. Okay, so all we have here at distinct, um, you can't see USA twice, you can't see Israel twice, you can't see Russia twice, you can't see Norway twice. You will see them once. Okay, so I want to use this and please pay attention to this. And this is one of the things that we'll be doing tonight. So we ran at first and we got a very long list that has repetition. what that is doing to us, though we can't know it because we're not paying from our pocket. So see what had happened. Now, 122 rows was generated um, in the first query that we ran, and now just 28 rows in this that we actually had this thing to. The difference is that the work my local machine did in the first time is more than the work it did in the second time. So you want to ensure that you reduce the lines of query you write so that the work and the space, because all of these things that you're doing, you think you are just clicking run, it is eating up space. It is it it has to do with the space on your local machine, and it also has to do with um, the the time it takes to actually execute the query. So you want to be sure. And is it SQL? I just want to recall if it was SQL that some people almost lost their PC. I think it's either SQL or Python. And this is not to scare you. I'm just emphasizing the importance of of um, of optimizing your query. Just search for what you need. Search for what you need. Search for what you need. So and that's it. So I will dwell so much on it later. So yes, we were trying to look for what the the different countries that we have in our data set, and that was when we saw US last time. We picked US. And in his own case, he went with France, and someone else could decide to answer that question with Norway. So, no country of preference. The only thing we just want to achieve is that you are able to do write a query to pull such a data. So, let me just quickly do that. Remember, we have int to use the customer, the order, and the other details. And last week, while I was doing this particular, treating this particular question, I pointed out something to you that necessitated the use of product lines. Yeah, yes, I think product lines is where we have description. Do we have description? Yeah, product name. Yeah. So yeah, it is product, not product lines now. So we want to get the product, want to get the want to get the product, that is the total quantity of each product ordered by a customer. So now for us to first identify the product, we need the product name, and the product name is not in order details, is not in order, is not in customer, because these are the tables that are very close to the table that has country. Remember, country is from customer tables. So we have the column quantity, country here, and we don't need anything in this other table, but we do need something here. And the only thing that matches is the product code. And we said we don't just want to put the product code because you will be given this operations team that needs this report a work to do in actually getting the product name. So why not? Since other details is connected to product and we can get product name easily from here, why not just do that extra step and get the product name from here? Then the using whatsoever connect both of these, and then get the country here, and then sum up, because we're looking at totals here. So we're looking at the total quantity, the total quantity of product order by customer in specific country. So we'll not be going by individual country. We just want to see a product, the total quantity that was ordered, and also and in a particular country. So in this same, we say um, in the United States. So now we can just write this query, say, um, okay, now that we already know this, we don't need it again. So we'll be using the, okay, so this is another way that I could use, we'll be using the product table. So let me see, and we needed the product name. So the product name is here, so we can give product table P as the alias, and we'll say P dot product name, product name, and so just for the sake of people who will be listening to this and who possibly won't have listened to the previous or won't have the privilege of going through the previous recording, don't let me start this with P. So let me just say product. So because, and why I'm adding product here and say product dot product product name is that this is the table where product name is contained in. So because I have the intent of using joins, so that's why. And when I'm joining, in this case, I'm joining more than one table. So that's why I had to go this way, um, calling the table it belongs to, then with the dot connecting it with the column that I want to pick. And then remember, we need the total quantity. And so I will just do a sum. Um, so I will do a sum. Okay, of the quantity. Now, to get the quantity, I think so. We need to look for the table that has the quantity that we're looking for. Um, I'm going this slow so that it can make sense to everyone who is following. So in other table, do we have anything like that? Okay, great. So in other details, we have quantity ordered. We have quantity order. Remember, we want to know the total product that is being purchased in a particular country, like putting it that way. So we need this quantity order, and we want to sum up the quantity order for the entire country. So this is what we'll do. We call this is order details table. So we then say, uh, we then say order details, order details dot. So we need quantity ordered. So quantity order. So remember our area. So we don't just want to have it as this. We just want to say total quantity. Say total quantity, and okay. So that will be good because what we just need is the total product that was purchased in a particular country. So we just gave, I mean, the product name and then the total quantity. So we'll be doing our joins on first is the quantity because we'll be sorting by country. I mean, we'll be filtering now, not so. We'll be filtering by the country which is in this particular table. So we say has C. So this is, and then we do our inner join. So the first table we'll be joining will be the order table in order of connection. Remember, customer table, order table, order details table, and then the products table. So, okay. So we now join the product table. No, the order table now. We now join orders, and so at this point, yeah, we can give orders an alias to say as oral. So and so on. So what is the thing that is connecting both order table and the customer table? So just hovering on customer number. In customer, it is sales rep employee number, and in order, it is customer number. So we'll represent it as such. So on C dot sales, okay, equals O dot customer. Yeah. Is that correct? Yeah, perfect. Oh, okay. Both of them have customer number. Yeah, both of them. So this is a foreign key, and yeah, both of them have customer number. Apologies for that. There, that's why I need to confirm that customer number. Okay, good. So we've been able to join these two, but we continue the joins um, because we've not gotten to the whole length that we're going. So now we are on order. So we need to then join order details to order. So we continue in the same vein, join order details as OD, we can say OD. So since we've declared this as OD, we might as well reduce these long order details to just be OD, okay? And we're joining it on, so let's see what relates both of them. Okay, so order number, all right, order number. So order number is same in both. Okay. On um, order number equals OD dot order number. Okay, now that is well joined, and then we go to the next level, so where we'll be joining order details table with the product table the same way. Now join products so we'll just give it the alias P, and since we've declared this, we can go up here and then take this out. Instead of writing products anywhere, we should have written product. We can then replace products with P now that we have declared it so to be on. So let's see what they brought. So other details, so what connect them? So product code, product code. All right, product code. So we go on product code. Product code equals od no p dot product code. Okay, now we successfully join everything together. But remember, we have um, a filter which is the country. Okay, we have the country, and remember the country is from the customer table which we have declared as C, and then we can come down to where we have country and say where country equals we can use any of those. Yeah, it's even right here before me. We can then choose Australia this time around. So say Australia. Okay, and choose to group by um, the product code. So no comment out. Okay. Oh, syntax error. Okay. All right. So now I think we have fulfilled all the condition. So this is what we need: the product name, and then we need the sum of the ordered quantity, and we need it in a particular country, which in this case is Australia, and then we run. Now, running this should give us our desired answer, or things being equal. All right. Okay, good. So remember that I said something about this as well, that we can export it and then give it the name that we so please, or we can also do some editing from here. I won't be going to that now. So this that we did, this particular code that we ran is good. It gave us the desired result, but is there a way that we can do it that can be better? You remember I was talking about runtime and also the space it consumes. So there are methods by which we can actually um, nest these things, or we just create a virtual table. So we can create a virtual table while running a query. So by the time we create that virtual table, it won't take any space. Um, the what's it called? The table will just be in the short-time memory of our workbench, and it will be able to recall whatsoever we want it to recall, and at the right time. So, and this is what I mean. It is good that we're able to write all of this and it works. I mean, kudos to us that we were able to put this, and this is what we need, and we don't need anything better than this. But is there a way that we can actually write this in an optimized manner, whereby we're not using as much memory that we have used in running this? Because take it or leave it, you're consuming memory as you're running these things, and also your machine performance. Um, because I mean, we're working. I don't know the number of column that this data has in total, but you possibly will find yourself in in a pool of data where, I mean, billions of columns. I mean, thousands of rows or even millions of rows, and you will run and your system might even freeze um, um, as a result. But we can, instead of having to bring everything together, writing them out this way, we can create um, what we call as views. So views, so they help us in actually providing for a virtual storage of our of, of our of our queries. So now you want to write something and you employ views to help you to actually um, save up some of the things you want to write because you need it to call. I mean, you want to call it back later. So you can create a view, and views will actually save it somewhere virtually. And when I say virtually, it just save it in a short time memory. So, and by the time you want to have a use of it, it then brings the table for you because you will be calling the view and it will bring it out for you. So, two things, it won't eat up your storage space because it is not storing that table for you. And also, what it does also, it helps the runtime to be very to be optimized. It helps us optimize our query. Okay, so let's see what view can do to what we have written. All right. So, and how to create view is very simple. So I won't take this out. I'll just create a new sheet that I'll possibly bring here. And now we want to create the views for this. Okay. So we go by say create views. So what view do we want to first create? So we want to break down what we needed into parts. So instead of doing all of the operation at once, we want to break it down into bits so that what we'll just be doing at the end of the day, we'll just bring all those bits together and we'll just make it one without having to consume any space. So the first we'll be doing is actually just to first have the order, get them in a way that we already join the order table and the customer table, and now we have our country in a side. You know what we did here? We joined all the table, we still apply filter for the what's it called, to get the country that we're looking at for. No, but this time we want to perform the filter separately. We want to get the total quantity separately, and so that by the time we now want to run what we will be using our space for, that is our PC memory for, it will just be us picking those two virtual tables that we've created and then getting result out of them. So it will look, I don't know how best to explain this. Okay, so you need to carry two jerry cans of you need to get water from two jerry can, 50-liter jerry can. Instead of you carrying the two 50-liter jerry can, how good will it be for you to have somebody carry it for you, and all you are doing is just to carry the basin you want to empty those jerry can into. So that is what Views does. I mean, maybe for the want of a better explanation. So instead of the PC carrying those 50 liters of water by itself and then getting to empty it into a basin, so views will virtually lift them. So for you, and then all you need to do at the end of the day is just to come and say, write a simple select query And so let's see how that works. So now we create the views, and like I said, the first thing we want to do is on the filter, yes. So we say create, so we give the view a name because that is what we use in calling it eventually. Just a minute, please. Okay, so we create a view that is called, so the naming convention I'll just adopt here will be this, capitalizing each word, order in country. Yes, let me adopt this. Okay, as so I'm creating this view that is order in order in the country. So I'm creating it as what I am about to create. Okay. So okay, let me continue. Just follow through. Select. Just be running your mind through what we have just done. Okay. To others as O. So I haven't done that. You can take this out and say O. Okay. So I haven't done that. We can take this out and replace with C. All right. So just the same way we write it the other time. Uh, let's use Australia so that we can compare the result. All right. So this is a view that has already been created for order in country. So what this order in country, that is what we want to achieve. We just want to get what are the order that that we had in this country. So with this, we didn't have to join all the tables at once. So we just did one join, and we have created this virtual table order in country. So virtually in the mind of our database, or maybe our environment, our work environment, which is the MySQL workbench now, a we have a table, a virtual table that is called order in country. So, and what this order in country does is that it has taken all the order together, and it has more like it has the order name, the order number, it has the customer number, it has the country. So every order, now when I have a table that has three columns, excuse me, we have a table that has three columns that now represent the virtual table called order name. So remember, okay, let me move forward and then create another view. Remember the analogy of the two jerry can that I was given, just for the want of a better way to put it. So now this one that I want to do will now help us to do the sum of um, the quantity that was ordered. So this will help us to do the sum of the quantity that was ordered. So we can have this as say another view that will be say create view. Somebody's already wondering that, oh, this is even longer than the initial one. So let me now say it. Remember the example I gave about select country from customer, and I said that wasn't optimal enough, that select distinct country from customer is more distinct. But did you observe that we wrote more code to make it optimal? So thinking about that. So is it that you do the front end loading by putting in more work initially and then have less to worry about computational speed and also the storage space. So I will write this and call it, say, let me use the same means product quantities. Okay, so we are creating this product quantity as, all right, as. So we'll do select um, so now we're still running with our products. Yeah, this is now the product side. So this product code. No, no, sorry. Product have product code, product name, and then we do the sum from this. Okay, got to carry the word. Product code, product dot product name, and then we perform the sum of the ordered so that's from order details. Details open correct. Okay, order details. Dot the quantity ordered. So we can give this the same name we called it the other time. Total okay. So now we do our from. First is the now. So this is something we should pay attention to now. Remember, so that this won't get complicated. Remember what we did here? We joined these two tables, order and customer. And it is just as simple as what we did before. We've joined order and customer. Now it is time to join order and other details and what's it called, products. But we don't just want to join them alone. We want to join these two that we had already joined. We want to join it to them. So that is the step now. So in case you see me write from order in country and you feel, where is this coming from? Excuse me. From order in country, and we can just give it an alias, say OC. So we'll now do our inner join. So what do they have in common? Now look at the table above. I mean this view, which is actually a virtual table, like I said. So what do they have in common? So this table, other details have other number, but we can confirm that. Yeah, other details have other number, and this table that we have created, because we created this with what we want to use it for in mind. So we added this to what's it called, to as a column in order in country, because we know we have a need of it here. So we're joining them on that which they have in common. So remember, we have actually given it this alias, and we say OC dot order number. OC dot order number equals OD now. OD dot order number. So we can just quickly change all this to OD. So we can just, okay, we've not declared this, we can leave it to be. All right. So I haven't done that. Then we'll now join the product to it. Now join product P on. So with that, we can change this to P. We can also change this to P. All right. So what? So this is direct. This is just like what we did before. What other details have in common with product is the product code, right? This is the product code. Yeah, product code, product code. Okay. On um, equals p dot p dot product code. Okay. So since we have done our filtering at this level, so we can just apply a group by here. Remember we did group by the other time. So remember the last time we just did group by the um product code, right? Yeah, product code. But this time we'll be grouping by both the product code and the product name. All right. So now we've created these two tables that will perform the work that we needed to do. But what we have just done is that we've just gotten that strong man that can actually help us carry those jerry can. So we need to get the person that will actually empty it into the basin. So that's small, what's it called? That small select code that will just execute the work, and that is what we count. All of these two, no matter how long they are, they won't count on our memory. But this is the only thing that will count, and that we affect our speed, and that's what we optimize the process, the running time. So this is what will actually impact the running time, and that's why the running time will be significantly low. Um, product name, comma, remember the total that we already have, total quantity, total quantity from this table that we created, from this table, from this table. So this is what we count. This is now what we are going to run. But I mean, this is what the PC will see us running, because um, these two would have done the work that we did in all of this. So they would have done the two, created the two virtual tables, and by the time this is run, we'll just have um, the results that we have. So running through it again, we have these views. So like I said, views are just a virtual storage space. It is used to create a virtual table, so to say. So now, in the mind of the workbench, we now have a new um, a new table called order in country. So now this order in country has been created, and what does it store? It has this table called, I mean, this column called order number. It has order name, customer number, sorry, and it has customer country. So these are the three things that is there. And how were we able to achieve this? We were able to achieve it by joining the customer table and the order table. So now, and we have actually done the filtering by country, and we said we're looking for just Australia. So even instead of having this, we can just even write this as others in Australia, so that in the event that we want to um, do for USA, it can be easier for us. So we can just say this is OA, and then we just follow it up wherever we applied it. So, okay. So, I mean, that will make it more um, clear, because since we have said we'll be using Australia, so order in Australia, so this will give us the order number, the customer number, and the country, which is definitely Australia by the time we apply this filter. But without this filter, it will give us all the order from all the countries. But because we have applied um, this where keyword, it will limit it to Australia, and that's why it's good to just call our view or that table, the virtual table we're creating, as order in Australia. So now we've been able to get all the order in Australia in this particular table. The next thing we want to do on those order, because we've gotten their order number, excuse me, because we've gotten their order number, sorry, just a minute. Yeah, because we've gotten their order number, so and they were able to then link this table. So this table is now a table, a substantial table on its own, is substantive on its own. So we then initiate an inner join on this table with the um, with the other details table first, and then our result is then joined with even the product table. And what did we pick here? That we needed to get um, the the ordered quantity, and we can only get the order quantity um, the from the order details table, which is this OD. So, and also we needed the product name, because we don't have the product name here. We needed the product name, and that was what got us to go over to um, the products table. So, and then we linked what we have with the product table. So, and after doing this, the only thing that we have left to just run, knowing that we already create this table, so the final query will be running is just to select, because this table you have will will have actually bring everything here into this place by this joint that we actually created. So everything here would have actually come into this. Remember what I displayed the last time, where I said what we're doing practically is when we're applying joints, it's just like we're taking this table, this is the other table, we dump it on the um, customer table. Remember the sign for we're using inner join. That means we're taking those items that are unique to both tables. So, and based on the relationship we have actually established. And then the second time that we did the second inner join is more like we're placing the other details table into it as well. And lastly, then we bring in the product table. So this is what join does. So bringing the four tables, making them into and query that table. And I said something joking last week, and that is the fact that we can only query a table. So any way by which we can make all the thousands of tables in this particular database to become one, we must do, so that we'll be able to query it as one table. So because our queries that we write is actually writing like we're querying just one table. So all the joins we're doing is just to bring all the tables together, and then we query it, or create a new table entirely, and then we create that new table that now has everything that we needed in it based on the relationship that exists between the individual tables. All right, so let them get back to where they were, and then let's try and run what we have. All things being equal, we should have a success. All right, so that is a success, and that's successful as well. Okay, so now I think we should then export, and we use this small Excel. Um, okay, I saved this somewhere. I don't even know where. Oh, okay, okay, okay. I could have just changed this. Let me say one, and by the time I'm saving this, I should say two. So that means I'm saving it in downwards. Okay, so now we have that. I mean, don't mind the naming, just too lazy to name that folder. So let me try and retrieve it and say, okay, now, so this is the first table on the right, and this second table on the left. So we can just do something very quickly and say, is this, remember our Excel skills, equals this. Oh, okay, I didn't do the second equal to, equals this, equals this. True. So, okay, why is it not dragging across? So we have some false. Is it mapping well? So it didn't map well. Okay, equals this, this. Or maybe what I should have done, just bring them into the same table so they don't have to be thinking. Because I think the format of this document is even an issue on its own. All right, so we can take this out and say the simple way of checking. Okay, that means they are all the same, and say equals this, equals this. All right, so they're the same, and just by saying, so we have only true, and here also we have only true. So what that means is that it is correct. So what we have here is correct. So now, you want to ask me, why do we have to go all this length to just achieve the same answer? And that was what I told you first, the memory and then the runtime. So by the time you compartmentalize it, especially problems like this, creating views, so you'll be able to save yourself the stress of using up your your PC storage, And I'm not talking about these small codes that we're running. I'm talking about by the time we get into a serious one, I mean, in workplaces, just imagine yourself working in interbank settlement as their data analyst, or you're being the one managing the data or reporting on a very big, maybe like the microfinance banks in Nigeria, maybe you are the one doing the reporting of their inflows and outflows. Not just one. I mean, I'm talking about the whole country. So, and you don't want to also alter anything. And okay, that's another good part to note. See, anything I write in this place has nothing to do with my database. Even if I had written rubbish here in this view, it doesn't eat my database. It doesn't impact my database. So if you are working on a very sensitive data set, I mean database, and you don't want any issue in which you possibly write something on the data, so creating a virtual table, even you can create a virtual table, you can, what do I want to, how do I want to make it now? Even the existing table, we created this because we needed to actually solve a problem and we want to then break the problem. We want to create two separate virtual tables, and then we'll then run the query that will help us to get the result that we want. But you can just say, oh, because this particular database is very sensitive and I don't want to cause any permanent um, I don't want a case of me having a permanent, what do I want, alteration on this particular database, that maybe anything I just write now could impact the database. Not for fear, because I don't preach fear. So, but you just want to trend on the side of caution. So you can then create a virtual table and then you do everything you have to do on that virtual table. And the next we'll be discussing about um, is CTE. So those are also it's just very close to this, but it's called the common table expression. So this CTE is very important when you want to do some aggregate. Something happened last week. We did an aggregate, and I think it is on this particular question or on the next one, where we did a particular um, we've done an aggregate and we wanted to include another uh, column to it, and it was throwing an error. So with CTE, you can perform your aggregate in the CTE and then you come out to you then bring whatsoever you have from the CTE and then you run a basic query, and so that both will just join together and there won't be anything like an error. So, but I think I won't want to start that now so that we don't just rush over it. We can just push that over to next week, but we won't close the class now. I'll get your feedback and we'll answer some more questions from our table. So we'll answer some more questions from our table. I just said we should demonstrate that with this particular question because it was good for it. Because no, this was what we used it on. It was good for it because the number of joins we had to create were about 4. So then we can split them because creating 4 joins will increase your run time and also that it will consume while running. So that said, um, I just want to get feedback from the house. Let me get the teams. Yeah, so if you want a table for all what's it called, all the countries, so what you do is you want filter, you want introduce that part where we use where, and we can just quickly apply that here. Where is it? I'm not here. Okay, so yeah, look at it very well. Oh, should I do that to this? Let me just copy this and bring it to another place. Okay, so said we just want everything. So let me be sure we're correct. But looking at it, immediately we take that out. What we should have left is the product and this across the countries. Yes. All right, so we can just run this. But because of the aggregate is asking us to group by. Okay, so we can group by. But we'll not do the where. But we did go by this, right? So you have this from all the country. Okay. So now what you have now is the sum of sales for each of the country. Okay, it now does not matter which country. Yeah, it now does not matter which country. So it has summed it across all the countries. Okay, so a case where we now have it by country, yeah, both of them will just be, all of them will bear what country they belongs to. So if we now
Can
want to
we
filter
can
by
we
them, it is just
can
like our
we
Excel.
can we introduce a country column like
Yes,
a
I was actually trying to get there.
okay
So
sir,
if we
sorry.
introduce a country column, you know what that will do for us? It will still not um it will still not filter what we want out. And this is what I mean. So it will well, let me demonstrate something. Because we have used an aggregate, we have actually we've summed up the quantity. So that is for each of the products. Now we have actually used product as our reference. So, and we have summed up each of the each of the quantity of the product. Now, remember that these products are purchased across countries. Now you have summed it up and you already have that is in each of your rows. All you want to be saying is that is this is this sum. Please try and play along, because if I should introduce this, we'll run into an error. Column for country, that should be C dot country. And I just want to explain why the error will come. So I want to explain why the error will come is that now, okay, wait, let me go to the table that we downloaded. Now, okay. Delete this. So this item, this first item, this 1996 Moto Guzzi 1100 high, we have already aggregated it to be 141. That is the total quantity that was ordered. But remember, this line alone, so where putting country here because this is literally what we're doing, only that we're doing it in query sense. Remember, all this quantity, even removing all of these people, um, so we can undo to bring them back. All this quantity, if we want to, how it will stand in the table is that, let's just choose maybe 3 countries, not to make it more complex. So let's share this across. Let's give one country 1, another country 100, and this one to be 40. And say this is USA, this is um, Nigeria. Let me not say Nigeria because it's not on the table. Don't let me confuse things. I think I saw France on the table and I saw the country we used the other time, Australia. Okay, good. So we are zooming now. So now, these 3 countries, this total quantity that we have in this column, the 141 that we have, is actually from these 3 countries. Now, this 141 is now being entered against the product, and now you want to bring the quantity. Which of these 3 quantity do you want? I mean, as a quantity, which of these 3 countries do you want it to bring here? Did you get the logic now? Now, because we have done aggregate, because we have summed up something, and what we summed up was over this, was for these 3. So which of these country do you think it will put here? And that's why it will return that error. So you can't you can't give us the country, you can't give us a country this, or say country this plus. Okay, so no, I mean, so that is what you are telling it to do by creating a column or selecting a column country in the expression that we have written. I hope I'm clear. But if we want to have it so that it will show what it is for all the countries, so what we are saying in essence is this: we'll just won't do this, but we will do this. So if we should run this, what we have now, if we export this particular one, and 3 or 4, and I go over there, and I go over there and I do this. Okay, that particular what's it called? Product. Um, so now, what we did is we removed Australia as the filter. So now it is giving us for all the country. So it's giving us for all the country, and that's why we have this 991. But the quantity we have in just Australia was 141. So that means we have other in this, we have others in this. So that's what we have. But I just use this quantity of Australia to explain why we can't have it in that form. So that's just it. But there is a way to actually get that done, right? There's a way that we can achieve that. We'll achieve the sum in each of the country, but not this way. We'll achieve the sum in each of the country. So I'm not saying that is not possible, but not this way. All right. So I wanted us to pick this next one and quickly run it through. So that one does. No, this is no. We did this last week, right? Yes, we did this. If I'm correct. Oh, we didn't do it. So we should be here then. A product manager is analyzing how would you determine the total revenue for each product line by combining this and this and this table. So total revenue. So how do we get the total revenue? It's just the amount that was paid for um, those products. So the total revenue for each product, right? Of each product line. So what we need is just the product name and the total amount that was paid. So if we do that, we have the product name here, we have the product name here, and we have the total amount where. Where do we have the total amount? Price is, buy price. So we'll just do the product. Okay. So we do the product of the quantity and the price each, because this buy price, you know, buy price to us. So see yourself as someone working in this company. So buy price is actually the cost price, that is the amount we bought this from the market and we want to sell. And then this price each, that is the price that we are selling each product. So don't confuse buy price with price each, right? So I mean, those are some of the things, and that's why you see some of us, when building a database like this, I would never put this to be a buy price. I can, even if I want to use a word like this, it will just be buy cost. So let cost go for the amount that you use in buying the product, and let the price that you are selling it be the selling price. So the cost price and selling price. So we just go back to our basic economics. So and so what we do, we just do the product of um this buy price and the price each, excuse me, the price each and the quantity ordered. So by the time we do um this product, and then we sum it across all the occurrence of that particular product, we'll get what we're looking for. So it should be very fast now that we have a very good understanding of the basics. So um, we can just do select, okay, select product, the product name, and then we do this arithmetic of say um, some since we need the total revenue for each of the line item, and to get even the selling, I mean the the total amount of each purchase line, I mean each sales line, so to say, the total amount of each sales line, we don't have it in our table. I just scanned through the table now. I don't know if it is somewhere, but the closest I have to it is quantity order and price each. So if two was ordered and the price of one is $2, it will just be 2 times 2 to get the amount of that particular transaction. So to get the amount of that particular transaction. So I don't have any place where the total amount was mentioned in any of this. So I can just quickly do that. All right. So so they are in other details. So the quantity ordered and price each both are in other details. Okay. Other details dot quantity ordered. So you remember I said the product of both of them, other details dot price each. So that is all we need. So once we've done this, and we can just give it an alias and say total revenue, right? Is that what they say we should call it? HR, no, not HR, no. Yeah, total revenue for each line. So we can just say this is the total revenue. So this is the total revenue. And then we'll quickly join our tables. So what table are we joining? We join the product table with the other details table, which is quite straightforward to do. Okay, they want us to join these three tables. Why should we join the three tables? So yes, okay, let us use the three tables as the hint. Sometimes it is just to test your what's it called, the way you can actually use it, so that you don't just because if I had just limited my search to these two, let's see what is in product line. What product line could give us in this product lines? Oh, could it be that product lines? Oh, see, this is where the cache is. Please always pay attention to details, and that is the work we have. If other people don't, we must. So I was trying to investigate why product line was one of the hints, and there I found that it wasn't just the product name that they were looking out for. The product lines is actually what the question is all about. It is analyzing the sales of each product line. Each product line. Each product line. All right. So great that we cached that before we went any further. So we can then do product lines now. Product lines. Product lines. Don't. So what is inside the product lines? So we have product line. Product line. The product line. Okay. And then we have the sum of this and this. Okay, as that. So we are selecting from. So let's start a link for product line. So product line is what relates both of them. So product lines. So let's give it an alias and say maybe PL. Product line PL. So we can do PL for this. And say inner join product. That's P. And then, okay, so on product line is what's the both have in common. So product lines equals P dot product lines. And then we do join other details now as OD, and we then place all this. Okay, I always do that one after the other because I want anyone who just picks up this recording to know why and where OD is coming from. It can be sometimes confusing if you are looking at something and it was, it has already been, the alias have been applied before they get defined. So let's see what they have in common: product and this. Okay, product code. Okay, product code. OT dot product code. All right. Then let's do our group by MPL product line. And all things being equal, this should give us what we're looking for. Look again. So this is what we want as our total revenue. Okay. All right. So now have, okay. So now product lines is like, I'm very sure we know that the product line is different from product name. So product line is more like the categories, and product names are the it's a sub of that category. So that's the item that are in that category. So we have classical, motorcycle, plane, ships, and likes. So and we have the total revenue from each of them. So I think we've done justice to that, though very fast. But good that we paid attention to this. We could have been doing something else. All right. So please pay attention to every line, and thank God for the int. If there wasn't an int, possibly would have gone our own way. But pay attention to everything: product line, not product name. And yeah, thank you for being a part of this. I think we've gained one or two. Don't forget this part CTE. You might want to go read up on it, and you might want to look at this again. The recordings, just to understand why we need CTE. And am I saying CTE already? Views. This is a view. This is a view. So why we need view? And please read up CTE, because I will be explaining that next week as well.